So we wish to compute this integral by using cylindrical coordinates. To do that, we begin by expressing our domain in cylindrical coordinates. So these are r, theta, and z. And we see that we have a cylinder of radius square root of 2. And the angle theta is going to be between 0 and pi over 2. This is because if you look at these two inequalities, that place the cylinder above the first quadrant of the xy plane. And finally, z, which doesn't change, is going to be between 0 and 4. So our integrand is going to simply be r cosine theta, and our Jacobian is r. So we'll go from 0 to square root of 2 dr, from 0 to pi over 2 d theta. Oops, sorry about this. Okay. So we were at d theta. I guess there's a small problem with Zoom, but in any case, and dz will be between 0 and 4. So now we can integrate, and we integrate first with respect to r, so we get r cubed over 3 from 0 to square root of 2 times cosine theta. And then we need to integrate from 0 to pi over 2 with respect to theta, and finally dz from 0 to 4. So this will give us square root of 2 to the third power is 2 square root of 2 over 3 times cosine theta from 0 to pi over 2 d theta, and from 0 to 4 dz. And this is equal, we can take this to square root of 2 over 3 outside. The antiderivative of cosine is sine, and we want to go from 0 to pi over 2, and eventually we want to integrate this with respect to z from 0 to 4. So sine of pi over 2 is 1, sine of 0 is 0, so that will give us 1 in here. Again, Zoom is playing games to me. Sorry about this. And we're going to get 2 square root of 2 over 3 and 0 to 4, 1 times dz. And of course, the antiderivative of this is z. That gives us an integral equal to 4. So we will have 8 square root of 2 over 3 is the final answer. And that's it. I'm sorry again for the Zoom mishaps, and I hope that you enjoyed this video. Thanks for watching.